recording here. Let me open my page. Do you see my screen, guys?
Yes.
Okay, perfect. So the assignment for this weekend, guys, has a mixture of two models, okay? One of them is an econometric model that you know is the OLS, and the second one is what is called the capital asset pricing model. Both models are very, very useful in both economics and econometrics. So what I want from you, let's talk a little about the ordinary least squares. I'm pretty sure you are familiar with this model, right?
Yes.
This is basically known as the OLS model. Okay, so what is the basic concept very quickly is that I have one independent variable, or what we call exogenous variable. And then we have my independent variable, or what I call my endogenous variable. And so the OLS model, guys, is a linear model. So basically what we try to do is we try to fit a line in a cloud of dots. These are observations, X and Y's, okay? Imagine marketing expenses versus profits, something like that. And what we try to do is basically try to find a line that best fits these dots. Do you agree? And so what is the criteria that we use here, guys? Why is it called the least squares model? The basic criteria that we use here, guys, this point here, the distance between this point here and the line, the equation of the line, remember, is a plus bx. And in econometrics, we use an additional term, e. This is our error, right? And this error has a bunch of assumptions, okay? The thing is, what I try to do, the distance between an observation and the line is what is called the error, okay? Error at observation 1. So what this model tries to do, guys, just to fit the line, is try to minimize the sum of the square of the errors. That's what this model tries to do, okay? And basically what it's trying to do, trying to minimize the sum of square of the errors, simply tries to make the line in such a way that the errors in the top cancel out with the errors in the bottom. Make sense to you, guys? Okay. So in general, guys, in a multivariate, this is the univariate OLS model. In general, what I want from you is for this homework, guys, you cannot use the MATLAB function. Okay, there is one MATLAB function that does this immediately. What I want from you is to use the Excel file that I gave you plus the Word document that I sent you to understand the model and try to model by yourself. So you need to use the mathematics in your program. Okay, so in general, guys, the model looks like this. Okay, so I have alpha plus beta 1 x1 at time 1 plus beta 2 x2 at time 1 plus, let's say, beta k xk at time 1 plus my error at time 1. This is my first line of observation. Second line of observations is going to be alpha beta 1 x1 period 2, beta 2 x2 period 2, beta k xk period 2 plus my error period 2. So if we have n observations, this is going to look like beta 1 x1 observation n plus beta 2 x2 observation n plus beta k xk observation n plus my error time n. Okay, so if we take a look to the model, the way this looks like a system of equations that we have worked in the past, guys. In this case, what I will do is I will collect y1, y2, yn in a vector. And this is what is important for me in order for you to program. This one here is going to be my vector of data. So, and I will multiply here by my vector of coefficients or parameters. So I will have alpha, beta 1, beta k, plus my errors that are going to be error 1, error 2, error n. Okay, so this one here is going to have 1, is going to have beta 1, beta 2, beta k. Oh, sorry, what I'm doing. Not betas, the observations. This one is going to have my observations. Is variable 1 at period 1, variable 2 at period 1, variable k at period 1. Then it's going to be 1, x1 at period 2, x2 at period 2, xk at period 2. If we do this, 1, x1 at period n, x2 at period n, xk at period n. Okay, so basically this is an n times 1. This is going to be an n times k that multiplies a k times 1, k times 1, and this is going to be an n times 1. If you multiply these two matrices, guys, indeed you have an n times 1, so everything is n times 1. Okay, in matrix notation, guys, this is going to be equal to n y equals x beta plus my error. Got it? And so what is that? The full idea of the model, guys, is simply to find beta. So find what is my intercept, what is my beta 1, what is my beta k, using the criteria of that the sum of the square of the errors should be minimum. Okay. So in this case, what we try to do is we try to minimize. Remember this one here? This is the sum of the square of the errors. And what you're gonna get, guys, is subject. This is minimizing beta, using beta. And then, guys, if you do this, if you do the mathematical exercise for this one here, what you're gonna find is that beta, the estimation of beta is going to be x prime x to the minus 1, x prime y, for example. So this is one of the equations that I want you to program in your code. Okay, and then you have the Excel file that I send you. Let me find the Excel file. I think I sent you the Excel file. Where's my? I send you one file, right? Give me 1 second. Let me find this very quickly. Okay, guys. So you need to use this file here. This is the generic formula. You can see how do we create x. So this is going to be my coefficients. So this is my data. This is my y. Okay, so if you put this in context, this is my y equals x. This is my x times beta. Okay. And then from here, guys, you do your x prime x. You multiply x times x, you get this one here. You take the inverse of this one here. Then you do x prime y. And then if you multiply these two guys, you see x prime x to the minus 1 times x prime y, you obtain a matrix. You're going to obtain a matrix like this. So A is going to be your intercept, B is going to be your coefficient 1 and coefficient 2. You have the data for this one here. So this is going to be your testing model, I think. You can use this model to test. And then you should be able also I gave you a Word document in which I give you the formulas for the R square, the standard errors, for the t-stats and the p-values of the t-stats. Okay, so you need to do that in your OLS model. Make sense to you guys?
Yeah.
Okay, so this is the first part of what you're going to be doing. So this is let's say part 1 of homework number 6. Now, the part 2 of homework number 6, guys, is a financial model that is a benchmark of asset pricing. Okay, the model. Let me save this one here for 1 second. The second model, guys, that we're going to be using is the following. Is what is called the capital asset pricing model. or basically CAPM. This is an M. Okay, so what is the basic idea of the capital asset pricing model, guys? Is the following equation. So they say that the returns of one asset, let's say returns of asset I, okay, are going to be equal to, or it's going to be proportional to the returns on the market. Return on the market minus the risk-free. So this is market return, market return. This one here is the risk-free. And as soon as I'm using the risk-free, I need to do something here. This is the equation. So how do we call RM minus RF? This is what is called the risk premium. Okay, so basically what it says is that indeed the return of an asset or the risk premium of an individual asset, this can be IBM, Amazon, Tesla, whatever you can imagine, the risk-free are normally 3 months T-bills. Okay, so normally the people use the 3 months T-bills here. Is proportional to the market. So the market return of the market is basically, we can talk about SP 500, we can talk about Russell 2000. It depends on what you define as a market, okay? But in general, they say that what IBM returns should be proportional to what the market returns. Make sense to you? Okay, and from this model here, guys, what we can take a look. Oh, so what is beta? Beta, guys, mathematically, this is the contribution. This is the contribution of asset I to the portfolio risk. Now, beta, guys, can be equal to 1. If beta equals 1, this is market risk. So basically, has the same risk as the market. If beta is larger than 1, it's an asset that is offensive or aggressive. If beta is smaller than 1, is one asset that is defensive. Okay, so one of the main assumptions of the model, guys, is the following. Let's take a look. I will write beta here, and I will write my expected return here. So when I have a risk-free asset, the risk-free asset has a risk-free return, do you agree? And the beta of the risk-free asset is going to be equal to 0. Okay, why? Because the risk-free is basically independent of the movements of the market, in theory. And then from here, what I can do is a line like that. So the return of the market. So if my portfolio is given by the market, imagine I select SP 500. This is my portfolio. What should be my beta? My beta should be 1. Agree with me, guys?
Yes.
Okay, so now how the model works. So this is what is called the security market line. So SML is security market line. Why this security market line is so important, guys? Because of the following. Imagine, guys, that the market return equals 10%. Let's assume that the risk-free equals 3%. Got it? And let's assume that the beta of an asset equals 1.5. Got it? Given this information, guys, what should be the expected return of asset I? When I do an start here, is expected based on this model. What should be the expected return of this asset? Okay, some answers. Guys, you have the model. The model is here.
%17.5%.
17.5%. Okay, so let me do this. Okay, I have Ri minus 5. Okay, everything in percentage terms equals 1.5 that multiplies 10 minus 3. Do you agree, guys? 7. So 17.5% you said?
Yeah.
Okay, someone to confirm?
Yeah.
Okay, so what is the meaning of this 17.5%, guys? The meaning of this 17.5% is the following. Let me move here. So this means that if we have an asset that has a beta of 1.5, according to this model, the return of this asset, and of course, this is 3% for the example, this is 10%. According to this model, guys, they should return, this is my RI should be equal to star, should be equal to 17.5%. Okay, so this is my model. So that's why the CAPM model, guys, is a benchmark model. Okay, the benchmark model by definition means that in theory, this is what should happen, right? But in real life can happen something different. So let's assume now, guys, that in real life, this asset is returning 20%. This is real life. This is return of asset I, real life. So this is, the model tells you it should produce 17.5, but in real life it's producing 20%. Make sense to you? Do you understand? Guys, do you understand what is going on here?
Yes.
Yeah.
Okay, perfect. So what is this difference? This difference, guys, is what is called alpha opportunities. So if someday you go to the business, to the industry, guys, the people always going to be talking about alpha opportunities. I have a model that creates positive alpha opportunities forever. They can tell you whatever. But an alpha opportunity, guys, is simply the difference between what the model tells you, in this case, the CAPM model, versus what in reality you observe. Okay? So what happens if you see this type of alpha opportunities? What do you do with this asset, guys? You buy or sell? Guys, you buy this asset, imagine this is IBM. In theory, IBM should produce you 17.5, but IBM is producing 20%. What do you do with this one here? You buy or you sell? IBM. Guys, if something is giving you more than expected, it's good or it's bad?
Good.
It's good. So then what do you do?
Buy.
Normally you buy. Now, when you buy, what happens with the demand of the asset increases? What happens with prices? Prices increase. When prices increase, guys, returns decrease.
Decrease.
So basically, that's why it's called an equilibrium model also, or a benchmark model, because this type of discrepancies, this type of alpha opportunities, if they exist, the market is not stupid. The market immediately is going to start buying, demand is going to increase, price is going to increase, returns are going to decrease. Are going to decrease where? In equilibrium, they should go back to this point here. Makes sense? Agree with me or not, guys?
Yes. Agreed.
Okay, so there is, of course, this was the optimal case. What happens if your asset is supposed to provide you 17.5, but indeed provides you only with, I don't know, let's say 14%? This is another case, okay? So this is case A, case B. This is also called alpha opportunity. Oh, I don't see this. 1 second. This is also called an alpha opportunity. But in this case, what do you do? This alpha opportunity is bad or bad? Or is good or bad? If you have one asset that is supposed to produce 17.5 and it's only producing 14, what do you do with this asset? You buy or you sell?
Sell it.
Sell it. Okay. I will call on top short. You sell it. So if you have the asset, you sell it. If you don't have the asset, you get you loan the asset and you sell it in the market. So what happens when when someone sells, or a lot of people sells, demand goes down, prices goes down. What happens? Returns goes up. So you basically go back again to this point here. Okay. So these alpha opportunities. So let me tell you. Let me finish now the mathematical model of beta. So beta is a contribution of asset I to the portfolio risk. What is the mathematical notation of, what is the mathematical formula of beta? Is the covariance of Ri with the market divided by the variance of the market. So this is the formula of beta. And remember, guys, if you know the OLS model, this is exactly the definition of the beta. Okay, in the generic OLS model, when we do y equals alpha plus beta x, this beta here is defined as the covariance of y and x divided by the variance of x. So it's exactly the same formula that like the CAPM model. Do you agree? So what is the only difference, guys, between this model here, my CAPM model, let's call it model 1, and model 2? What is the only difference that we have there? That according to the CAPM model, guys, this value here is equal to what? In the CAPM model, this alpha is equal to what? Take a look. What is alpha here? Do we have alpha in this model? Well, we can have, but the alpha is short-term lived. Do you agree? These famous alpha opportunities. So what is the main assumption of the model is that this alpha disappear very quickly. So in average, you should have an alpha equal to 0. Agree with me or not?
Yep.
Yep.
Okay, so that's exactly what you're gonna be doing. So what you do in your homework number 6 is show a couple of things. Show A, are there alpha opportunities? And B, what is the beta of the stock? Let me save this one here and let's take a look, a very, very quick look to the data that I sent you. Let me show you the Excel file. Allow me 1 minute. Let me show you my screen. Okay, you see my screen? This is the model that I was telling to you guys. For this particular example, just to make your life easier, let's assume that risk-free equals 0. So basically, this is going to be the model that you're going to be testing. This is the econometric model. The CAPM model, remember, guys, assumes that alpha is equal to 0. Okay? You are going to have these data sets. You're going to have IBM represents your RI, your return of asset IBM, and SP500 represents the returns of the market. Okay? Now, sorry, these are prices. These are prices what you're going to receive. Now, the model doesn't work with prices. The model works with returns. So the first thing you need to do, guys, is to transform these prices into returns. How do you compute that? It's very simple. It's A4 minus A3 divided by A3. The next one is going to be A5 minus A4 divided by A4. These simple returns. Got it? So now you're going to have your data. So this is the data that you're going to be using. Make sense? I described here a little about the model. You are going to use your own OLS model, guys. So this is going to be the data for your own OLS model. And then you're going to create this one here. And you are going to find the coefficients. You're going to find the R squared, the adjusted R squared, standard errors, observations, the F, etc. So you're going to create your own OLS model with this data, okay, with this model. And then what I'm asking to you is this. This is what I ask you. The CAPM model tells you guys that, that the alpha, there are no alpha opportunities. Now, if you see just the number is very close to 0, right? Do you agree?
Yep.
And also, the p-value is 0.57. So my null hypothesis is that alpha equals 0. If you have a p-value equal to 0.57, do you reject or fail to reject the null hypothesis? Guys? Do you remember what is the rule, guys? Remember, guys, when you have an hypothesis, okay, my hypothesis in my model, in the OLS model, is that the first one is alpha equals 0 versus alpha is different from 0. Make sense? So my hypothesis is that alpha is not significant. And remember, guys, we use the t-test, the t-distribution that looks like a normal distribution but has fatter tails. And if I use a significance level of 5%, this is normally what we do, significance level of 5%. So what I'm saying is that the mass here is 95%. This part here is 2.5%. And this part here is 2.5%. So remember, this is the region not to reject or fail to reject, not reject H0. And here you reject, and here you reject. So do you remember, guys, what is the rule with the p-value? If the p-value is smaller than 0.05 or smaller than 5%, what do? Reject or fail to reject? So
Reject.
remember, if you sum, yes, exactly. If you sum these two numbers, it's 0.5. Do you agree? If you have a value, imagine you t-test give you a value like that, so that wait a second, I want to have this one. The p-value related to this one here is going to be this part here plus this part here. Do you agree? So if you sum these two blue parts, it's going to be smaller or larger than 5%? Guys, if I sum the blue parts from the red dot to the right and here to the left, if you sum these blue parts compared to the black part here, which one is better? Is larger? The blue, the sum of the blues, or the sum of the blacks?
Of the blacks.
The blacks. So, and the blacks are the the p-value is the blue, and this one here is my significance level. So basically, if my p-value is smaller than 0.05, implies that I'm in that rejection zone. Do you agree? So you reject H0. So rejecting H0 means, guys, that alpha is different from 0. And then you do other wild type tests to verify what is the most likely value of alpha. But indeed, if the p-value of alpha is smaller than 0.5, we reject H0. Okay, so let's take a look to the Excel file. This value looks very close to 0. But what about the p-value? My null hypothesis is that this intercept that I call alpha equals 0. What can you tell me about this p-value? Is this p-value smaller than 0.05?
No.
So
No.
we failed to project?
Exactly. We failed to reject. What we failed to reject? That alpha is 0. So basically what we are saying here, guys, is that indeed, at least with this data, the CAPM model is right. Agree with me or not? Because remember, the CAPM model assumes that there is no alpha. Here, we don't have an alpha here. And also in the model, in the explanation that I told you, if there are alphas, the alphas should be very quick, very short-lived, appear and disappear very quickly, because the market is smart, the market is looking the prices, and they react accordingly. Make sense? So according to this data set, guys, indeed, alpha equals 0. Indeed, the model, the CAPM model holds. Now, my second question to you guys is, give me, what is the beta of this stock? Well, the beta of this stock is what? Where's my mouse? Oh, here we go. The beta of this stock is this one, 1.1. Agree with me? Now, is this 1.1 significant or not? Take a look to the p-value. Can I assume that this is my beta, okay? That my beta is equal to 0? Here I have a p-value that is 0. Is 0 smaller than 0.5? 0.05?
Yeah.
Yes. So then what I do, I reject the null hypothesis that this value is 0. So indeed, we can assume that it's 1.1. There are other tests, guys, to prove specific values. But at this point, we can assume that the beta is significant and can be assumed to be 1.1. Okay? Make sense to you guys? Make sense?
Yeah.
Okay, so what is 1.1? Well, we are in a kind of a slightly aggressive stock. And this is right, guys. IBM is one asset that the people look besides SP500. It's like measuring the temperature. It's like confirming the temperature of the American economy, the American stock markets, for example. So beta of IBM has been always very close to 1. And also when we go to other countries, for example, Brazil, Telefónica. So the people look at Telefónica, not only the index, but also Telefónica to see what is the beta that is more or less correlated to the beta of the market. Okay? And so that's it. So that's what you need to do, guys. You need to use your OLS model. You need to use this data. You have this data. I gave you this data already. You need to transform the data that are prices into returns. And then you simply run your OLS model, verify this value, verify basically that your model is able to, your OLS model in MATLAB is able to compute this value, the p-values, the t-stats, etc. Make sense?
Yeah.
Okay, questions. And then you have a little more things to do with homework number 6 I opened just now. Thank you, Julia, for reminding me that I didn't put that. So then you need to do CAPM. This is 1 and 2. And then I give you data statistics. And for this one here, guys, I need you to take a look to the video. Okay? The video is 1 hour only. You can watch, of course, all the video because it shows more about creating tables, uploading MATLAB tables into Excel, into other programs, etc. But what I'm interested is you focus a lot on the polynomial fit, because the polynomial fit is another way of doing OLS, but in a more fancy, more easy way. Got it? And that's it. So questions. So I gave you everything, so you can have everything, you can analyze everything, and you should be ready to go.
Sorry, Prof. What about the project?
No, the project is we're going to talk about this next week, because you are
Oh.
working already in pieces for the project. Don't worry about the project. Once we are done with all this stuff, you're going to be the project is going to be a piece of cake for you. You're going to see that.
Okay.
Remember, guys, that the last day of class in a week, I invest more or less half of the time just presenting some more stuff. Then the other part of the class is to give you some ideas of the things you can do. And then you have until next Monday. So you're gonna have the class finishes on Thursday, but you're gonna have until Monday to produce your project. And I will explain to you guys how can you do a project in a much simpler way. I will show you. Okay. And that's it. You're gonna be ready for that. I will show you new technology, AI-based technology that is gonna help, gonna make your life easier once you understand what we have done up to now. Make sense?
Okay, thank you.
Okay, perfect, guys. So we see you on Monday. If you have questions, please email me. I always answer questions.
Thank you.
Okay, see you guys.
Thank
Take care.
you.
Have a nice
So much.
weekend. Bye bye,
Thanks,
guys.
Professor. Bye.
Bye.